Good evening, colleagues. My name is Brian. I want to explain the concept of confidence interval, particularly in the context of regression analysis. And the main reason why I've decided to take this video is to clarify a question that is arose in the group in relation to confidence interval and its interpretation. So the main intuition that we need to know here is that the confidence interval is just one way of checking the significance of a parameter in a regression model if we are economists running models. Okay, so the starting point for my discussion here is that assume, as you know, that as economists we're interested in looking at a relationship that appears like the one on the screen, in which we want to determine the relationship between x and y. So in this case, I'm just assuming that we are dealing with a bivariate case where we only have two variables, x and y. Now, as we all are aware that this is our intercept and this is our slope coefficient, we are usually interested in analyzing the effect of the slope coefficient. Okay, now so let's assume that when we have this model, after having specified this model, we estimate it to get the estimates of beta 1 and beta naught using some estimation technique, maybe the ordinary least squares. Okay, so let's assume for a moment that we have estimated using the OLS and then we get the estimated value of this. Now there are two things that we are interested in if we are researchers in doing our applied econometric work. The first thing that we're interested in a model of this nature is the sign that is next to the slope coefficient. Okay, is it positive or negative? It is because of this sign that will tell us whether the relationship between x and y is negative or positive. Okay, now the second thing that is important is to check the significance of the slope coefficient. By way of significance, technically speaking or literally speaking, it simply means we want to answer the question, is beta at 1 statistically different from 0? Is it statistically different from 0? Okay, so if beta at 1 is not statistically equals to 0, statistically, okay, then it basically means that x is a significant effect on y. But if beta at 1 is statistically not different from 0, then x does not have a statistical impact on y. Now, how do we determine whether beta 1 is equals to 0 or beta at 1 is not equals to 0? We do that using hypothesis testing. Okay. Now, hypothesis testing comes in two forms. Okay, so hypothesis testing comes in two forms. The first one is what we call the level of significance approach. So this is the level of significance approach. And then the second one is the confidence interval approach. Now, the key thing that you should bear in your mind is that these are two approaches which work differently, but they should give you the same conclusion as far as the significance of x on y is concerned. Okay, so let me just quickly explain how different how different these two approaches work and how they will reach a same conclusion. Remember, when you're using the level of significance, there are usually three levels of significance that we use. Okay, so the first, okay, so we have 1, usually 5, and 10, and 10%. So these are significance levels that you can use. Let's assume that let's assume that you are using 10%, okay, for argument's sake or for demonstration's sake. Under the level of significance approach, okay, so your alpha will usually be denoted as 0.1. That would be 10%. And we would start by specifying, the now, what we call the now hypothesis. The now hypothesis is simply something which looks like this. Okay. And then, okay, so let's just say the now hypothesis, which usually is denoted by H naught. And the alternative hypothesis will be HA. Okay, like this. So this will be the alternative. So now having specified or having selected the level of significance, and you specified also your now hypothesis, The next thing that you need to do is to formulate your T critical, your T calculated value. Now, so your T calculated, I'm just explaining something that I presume you already know. I just want to get through it quickly. Your T calculated would be, and by the way, this is stuff that you can get in any econometrics textbook, and I presume even in Gujarat you can get it. So, so this is the formula that we use to get the T calculated when we're doing regression analysis, hypothesis testing. Okay. So this, what will be this? This will be the estimate here that we'll get here, and what will be? Actually, I don't know what is happening with my laptop. It keeps on, giving me these popping these notifications, and I've been struggling to. If there is anyone who can assist me to stop these things, I don't know. Whenever I connect to the internet, I get some notifications on the bottom part of, and sometimes it's embarrassing. Let me see if I can manage to get over it. Yeah, I think. Yeah. Okay, so I was explaining that. Okay, so this will be the formula that we use to calculate the T-cal. Okay. Now the second thing is having. Okay, I think I was explaining that this we get it from this model. Okay, so minus. So this is the population parameter. Now, when you are now running when you have estimated your model and you want to conduct a hypothesis testing, you would then normally do this beta a to 1 minus 0, because the 0 is what we are testing here. We are saying beta a to 1 is equals to 0. So we'll say minus 0 over the standard error of beta a to 1. Okay. And normally other textbooks, because this you are testing equals to 0, they normally represent this as beta a to 1 over the standard error of beta a to 1. Okay. Now the second thing is the decision criteria would be to reject this null hypothesis when this T calculated is greater than your T crit. So which means you then need to compute your T crit, and for you to calculate your T crit, you need two things. Actually, one, you need your N, which is your sample size. Okay, so maybe you have 33 observations, and then you need your alpha, your level of significance. Okay, now your level of significance here, if you specify our null hypothesis like this, okay, beta at 1 is equals to 0, and the alternative being beta at 1 is not equals to 0, we call this a two-tailed test. Okay, so because it's a two-tailed test, we'll divide this level of significance by 2. Okay, so it's alpha over 2. So if you come here on a graph, we have alpha over 2, which basically means that we have 0.05 here and 0.05 here. And then we go to our statistical, distribution table, and then you go to a section of degrees of freedom. Degrees of freedom would be n minus k, where k is the number of parameters, and then when you do that, the section, that part where they intersect, that will be your critical. So let's just assume that you get this as minus 1.3 and 1.3 here, and then let's assume that when you use this formula, you get something like 4. Okay, so if you find your T calculated as 4, then 4 maybe lies somewhere around here. Maybe 4 lies here around there. And by the way, we call all these shaded parts the rejection regions. Okay, so they are the rejection regions. If your T calculated falls in this region, then you reject this null hypothesis. This null hypothesis. So if you reject this null hypothesis, then it basically means that X has a significant impact on Y, because beta at 1 is not statistically equals to 0. This is the level of significance approach. Now, if you are using the confidence interval approach and you have a two-tailed test, then it basically means that you have to construct two limits. The first one is the lower limit, and the second one is the upper limit. Okay, so this would be your confidence range. Okay, so that's where you find your 95% here at the middle here, and then these remaining parts, you have 2.5% and you have 2.5%. Now, the way the confidence interval work is, you would say beta h1 t plus or minus alpha over 2 times the standard error of beta h1. Okay, this is how we normally represent that. That's the formula of the confidence interval. So because we have plus or minus here, it means it's a range. Okay, so if we want to extend this formula, if we want to be much more elaborate, then it means we have beta h1 minus t alpha over 2 times standard error of beta h1, then we have beta 1, beta h1 plus t alpha over 2 times standard error of beta. Sorry, I don't think you'll be able to see. So this is 1 equals to 1 minus alpha. Okay, so this will be equals to your 95% confidence interval. Now, so this is what is beta 1, which is the population parameter. And remember, we are testing, if you go to the level of significance approach, we are testing that this is equals to 0. So basically, if this range, so this is the lower limit and this is the upper limit, if this range contains 0, then it's the same as saying this one does not affect y, because what we are hypothesizing, beta 1 is actually lying between the range. Now let me try to explain to you this in Starter, so that you can see that when Starter is giving you regression results, it provides the level of significance and confidence interval estimates altogether. And if you look at this, if you look at the two results, they will reach the same conclusion as far as significance of parameters is concerned. So let me just randomly regress here some variables so that I can just illustrate to you. Now, okay, now I want you to look at this data output. Okay, so there are just some variables that I've estimated for demonstration purposes, but they're interesting for one reason. One, they help us explain the different, like this important aspect that I want to drive home, which is to say the level of significance approach and the confidence interval approach will reach the same conclusion. Now, there are two areas that I need to emphasize on. The first one is this one, where we have the t statistic and the p-value column, and these two columns with the confidence interval. For now, let's ignore about this one. Let's start to explain. I'll start to explain this part. Okay. Now, if you look at this part, now when you are doing a regression analysis under the level of significance approach, there is one way of doing it which we are taught, in a statistical course, is you follow those procedures that I just explained to you. Like you specify your null hypothesis, you calculate your t statistic, you calculate your t critical. So that would mean you would need your statistical distribution tables, your t distribution, and so forth. And then with that information, you can then do it manually. But another way, under the level of significance approach, another way of doing the same is to simply look at the probability. Okay, so the probability value here will actually help you eliminate all those stages under the level of significance approach. For example, if you find that your p-value is 0.010, what we normally say is based on those three levels of significance, 1%, 5%, and 10%, you reject the null hypothesis if the p-value is less than any of those three, depending on which one are you using. So if your supervisor advises you to use 5% level of significance, then it would mean that this one is significant because 1% is less than 5%. Okay. If we go to the next variable, which is log exp, 0.89 is way above, the maximum, which is 10%, or 0.1, which means you cannot reject the null hypothesis. Okay, now this is the easiest way. If you want to use the t statistic, you would need that distribution table, but normally when you are just doing a paper and so forth, this should be enough. The p-value should be enough for you. Now, but those who are experienced in runner regressions, they will tell you that normally your t-statistic should be roughly around 1.9 for you to be sure that the variable is significant at 5%. Anything less than that, maybe 1.6, 1.7, even if you don't have a distribution table, that that variable is likely to be maybe significant at 10%, but not at 5%. Okay. So now I was explaining in terms of the p-values. So if you look at the probability values, you will see that this one tells you that this variable is significant. It has a significant impact on output. But this one is not, because the p-value is above 10%, 0.1. Now, this one is significant, but at 5%. Okay, so log imports have a significant impact on output. In other words, we are rejecting the null hypothesis that this coefficient of imports is equal to 0. We are rejecting that because the p-value is less than 5%. Now, this one is significant because it's less than 5% the p-value. The same, okay, not the same for this one. This one is 20. The probability value is 20.8, which means that this variable does not significantly affect output. Now, so these two columns, they are telling us that so we have 1, 2, 3. This one, and this one are the only significant coefficients, variables. So this, and this one, they are the only significant. Why? Because their probability values are less than 5%. I'm excluding this one because it's a constant. Usually we're not interested in testing the significance of a constant. So only 3, 1, 2, 3, they are significant. Why? Again, because the p-values are less than 5% if we are using 5% level. Now let's go to the confidence interval approach and see if we are going to reach the same conclusion. Now you see that here there is a 95% confidence interval. So this one is your lower limit and this is your upper limit. Okay, so this is your lower and this is your upper limit. Now the argument, if you still remember what I said when I was just demonstrating some brief steps, was to say your variable does not significantly affect the dependent variable if your range contains a 0. Okay, so if it does not contain a 0, then it basically means that it's significant. Now the person who asked, let me just check the name on our group. Your question was, okay, I'm sorry, I'm not too sure if I will pronounce your name very, very well. Asad Faroki. I hope I pronounce your name very well. So Asad Faroki, your question was, you know the confidence level, but you don't know the confidence interval. Well, this is now the confidence interval. Asad Faroki, this is now the confidence interval, and 95% is the confidence level. Okay, so because it's an interval, whenever you hear someone talking of an interval, there is a range. So there is a lower and an upper limit. So what you only need to know is the first one is your lower limit, the second one is an upper limit. So whenever these two ranges, whenever these two values contain a 0, then it basically means that this variable does not affect your dependent variable. whenever you see that the range contains a 0, you must tell your mind that the variable does not significantly affect the dependent variable. Now let's see if this is going to be true. Now let's start with this log CLR. Okay, now obviously whenever you see them having the same signs, it basically means that you cannot find 0 between those two range. And you see that all of these are positives. 0 does not lie here. Okay, so 0 does not lie between 0.03 and 0.02. And because 0 does not lie there, it means that this variable does not affect output, if you understand what I was saying. And I hope you can see as well that even if you come here, you are still concluding that this one significantly affects output. Okay, so 0 is not contained here, and here it was significant because the p-value is less than 5%. Okay, so the key point that I want to tell you here is this level of significance approach and the confidence interval, they are communicating the same thing, right? Now let's go to the second. The second, because this is negative and this is positive, it basically means it contains a 0. Okay, so if you look at the second, this second row, the range contains a 0, which basically means that this variable does not significantly affect your dependent variable. I hope you understand. And even if you go to the level of significance approach, you can see it is that same variable which was insignificant because the p-value is 0.89. Then you go to the third. All of these, they are negative signs, which means we cannot, this range does not contain a 0. Okay, so because it does not contain a 0, it basically means that your variable has a significant impact on the dependent variable. And this is true even if you come to the level of significance approach. The t statistic is minus 2.49 and the p-value is 0.013. Okay, so we reach again the same conclusion with the confidence interval and the level of significance. You go again to the next variable. This does not contain a 0. Okay, this does not contain a 0. So it means that this affects output significantly. And you reach the same conclusion using the level of significance approach. So I hope that this helps you. Also, if you remember, our conclusion was, if you look at these probability values which fall under the level of significance, we observed that this variable and this variable plus this variable, these three are significant, okay, because the p-values were less than 5%. You will reach the same conclusion if you use the confidence interval approach, if you pick the ranges where you do not find a 0. So this, it is this, it is this, it is this. So again, these are the same variables that do not contain a 0, and therefore the impact of the independent variable is significant. I hope Asad, you'll find this video useful. If you have any questions, and many others who have been watching this video, if you have any questions, just drop on the YouTube, and then maybe I'll clarify later. It's just a quick video that I did just now to help clarify one of our group members who was having challenges in interpreting the confidence interval. Thank you.